All right, so a little bit about myself. My name is Annika, and I've been at Tableau 2 years working on the pre-sales team. Rather than simply giving you a list of facts about myself, I know some of you attended the advanced Calcs session, so you already know about my love of clog dancing. I thought I would start us off with a very short autobiography. So when I was about 10, I used to love puzzles and numbers and being able to figure out the solution to a lot of world's greatest, at least numeric problems. In school, this translated into a passion for calculations. So for any of you other math nerds out there, I salute you. And when I joined Tableau, this translated quite well into calculations. So being on the pre-sales team, we get to see lots of different customers' problems and be able to work with them on creating real solutions for their business use cases. So whenever I wasn't doing that, I'd spend all my time here trying to figure out exactly what was going on and how I could best manipulate it. And this worked out quite well for me through my time at Tableau. And I just kind of went on trucking, solving individual problems, problem by problem, until I met the first customer that I'm going to talk with you guys about today. So we'll call him John. So about 6 months after I started, John came to me with this very problem. So he wanted to see the last 5 days that has data and only display that in his workbook. This isn't based on if it is a weekend or a weekday. This isn't based on a particular day of the year. John needed to look at if there was data entered and only then keep the last 5 times that this has happened. So I'm going to go through the solution to the problem at the end of this session, but I will give you a preview in that this involves 47 nested calculations to solve if we just stay in Tableau. And this worked OK against his 10,000 row sample data set that he had sent me. Right? As soon as we plugged this into his production database, it slowed performance to a level that wasn't going to be useful for his end users. And that day taught me a very valuable lesson that is kind of the reason I went through and developed the session to begin with. And that lesson is this: just because you get the correct result doesn't mean you solved it in the most efficient way. In Tableau, it's really not enough to just check that A equals A and be done with it. So I want to just give you a little bit about what you should expect to learn today. So we will be going through very specific customer examples and use cases and problems that I've seen throughout my time at Tableau. We won't have time to make this a totally comprehensive performance session. So if you guys haven't seen the Designing Efficient Workbook guide by Alan Eldridge, I encourage you to check that out. It's going to go through about 80 pages of some of these main topics that we're talking about today. We'll also go through how to think about challenges. We're looking at a variety of groups of calculations. So we're bucketing everything into string, table calculations, and level of detail, and how to think about these groups separately. And lastly, I hope to leave you with general tips to always design for performance. A lot of these recommendations aren't going to make material difference on a 10,000, 100,000 row data set, but I promise you that there's a day or a data set that you're connected to in which these will make material differences. And since in Tableau, if performance is bad in desktop, it's going to be bad everywhere, right? It's really important to always think about the initial design so that you don't encounter a situation in which performance is bad for the end users, and that forces you to start all the way from the beginning. So today, we're going to just be going over the performance recorder at a high level in conjunction to how to use that to troubleshoot whether or not something is wrong with your calculations that you're running. The majority of our time, we'll be bucketing our customer use cases into these 3 types that we discussed prior. After these 3 types, I will give brief pauses for questions, since, as we all know, performance questions can be very specific to your use case. Try to keep them general, and if you have more specific questions about your particular environment, happy to stay after and speak with you more in detail. All right, can I get a quick show of hands of how many people have used the performance recorder in Tableau before? OK, so about a third, a little more than a third of the room. OK, so the performance recorder is a great place just to start and to troubleshoot. So things that you'll want to ask yourself before knowing that this could come in handy is just, is your workbook slow? Right? If it's slow in desktop, it's going to be slow in everywhere. So rather than just trying to make changes on the server end, always go back to how it's running within desktop. And finally, the piece that we're really going to focus on here is, was it performant before you solve the problem? If you're connected to a live data source and your queries are just running slow overall, that's always going to be a issue no matter where you started. But if your workbook was performant and only after you ran calculations and solved your problem, then you saw a degradation of performance, this is kind of what we're troubleshooting here today. So just so everyone knows how to access the performance recorder in Tableau, if you go to the Help bar, drop down on Settings and Performance, and select Start Performance Recorder, that's how you get it going. Best practice here would be to not have other workbooks open, so you're not inadvertently using other resources. Also, make sure you're kind of starting off with a fresh connection so that you're not accidentally using the cache and the queries aren't being run. So then, specifically to troubleshoot this for your calculations, make sure you just recreate the slowest queries. Everything that you do after you press Start is going to be captured. So just keep that in mind if you're doing clicks for about 10 minutes. It's going to be a lot harder to figure out the part that you want to troubleshoot. So once you do press Stop Performance Recorder, you get a new workbook. This will be titled Performance Recorder V1 or V2 or V3, however many times you press Start and Stop. So just a brief overview of what this is going to look like. We have show events taking at least blank number of seconds. Best practice here would be to bump up the 0.00 to about a hundredth of 1 second, whatever you think would be material for you, because if things are running that fast, we're not as concerned about those. The timeline is going to show you all the queries that were run from the beginning to the end. And finally, the events sorted by time. So this is showing you what individual events took the most amount of time. And if selected, this is going to show you the query that's run back. Right? So if you haven't used the performance recorder in 10.0 yet, we did add more event groups to really pinpoint the type of queries that are being run back. And we want to know what kind of event groups correspond to what. So you can see there's a lot of different types. We're really just going to focus on two in conjunction with calculations. So the first one is the majority of our time spent computing layout? Could someone tell me what a possible view looked like if this is what the performance recorder is capturing? Yeah, scatter plot. Really anything that has a huge amount of materialized marks. So in this pretty bad visual design example, I'm rendering a bar for every day that I have of data, right? Because Tableau has to render every single pixel, computing the layout is going to take the majority of the time. And it would be hard to imagine a user could scroll through all of my different days and really get any insight out of this. So if we spending the majority of the time computing layout, think about how you can start by aggregating up the view so it renders faster, and then using drill down actions, still get them to the lowest level of granularity that they want to see, but only after they've decided what's valuable for them. And what we'll be spending the majority of our time on today is if the majority of the time is spent executing the query. So then we should ask ourselves, can we solve the problem in a different way? What's being brought back on either live connection or the extract is what's taking the most amount of time. So we need to figure out if there's a better way to solve this. All right. So now we're going to start by looking at string calculations first. So string calculations, this is not Tableau specific, right? This is really any system you're working with. These are going to be notoriously slow. That just has to do with the fact that rather than storing a Boolean value of true or false or a set number of integers, strings just take more to store because there's more possible values there. So our first customer use case I saw was I had a customer who had postal codes coming from her data. She didn't really like this view of seeing everything together, and she wanted to be able to filter on her states in order to then get to a more granular level. The issue here was that she didn't actually have state coming from her data set. She only had postal codes. And she correctly identified that each postal code had a hierarchical relationship with each state, right? Every postal code only belongs in one state. And so this was the calculation that was originally sent over. Yeah, not great, right? This, she had about 2,000 postal codes, and this matched every postal code to a string number to then bucket it in the appropriate state. So this is the most dramatic example I have for you today, right? But there are some lessons we can take away from this. And that's just about how this actually is being run. So this evaluates each line individually. If we have a 2,000th postal code, in order for Tableau to know what state that belongs into, it would first have to check 1,999 other postal codes, check that that doesn't equal each other before correctly bucketing it into the appropriate state. So then imagine doing that 2,000 times with a variable amount of tests that are run every time. Right, so this one is kind of your low ball of the afternoon, but we really want to bring in the postal code and state information directly from the data source, right? There are times where you can get the data just based on other things that you're bringing in. So you need to figure out how many string calculations are going to be run in order for you to get that result when you could materialize that data and bring it in directly. So our next customer use case within string calculations, it's likely going to be one that is a bit more familiar to us. So in this instance, we want to create a flag for today's data that's dynamic. The actual use case here was wanting to look at the average of today's sales versus all other sales, and then just a quick, is it higher or lower to track. So the calculation we started with to solve this problem, pretty simple. So if the date equals today, then today, else not today, right? This correctly groups data into two separate categories based on the test, date equals today that we are running. However, this still evaluates the expression, since it's an if-then expression, and it stores string results. But there's only two returns here, right? Something is either today or not today. And this produces a correct result. Can someone tell me how we could simplify that calculation? Yeah, just isolate the test. If we just isolate date equals today, then that's just being stored as a Boolean. We can still re-alias that. So the end user isn't losing any functionality. They're still seeing it labeled as today and not today. So that allows the end result to be identical. It just keeps us from having to store strings. So a few other things to keep in mind with string calculations. In general, right, else if is going to be more performant then else space if, creating a nested calculation. And so quick example of this calculation, this is first checking if the region equals East and they're in the consumer segment, then we know it's an East consumer. Else, it's running another test to see if they're not a consumer to group them in East all others. So here we can see we're running two nested statements, which would run back as two case statements. And instead, we can then simplify this to just look at if the region equals East and the segment's the consumer. So the first part hasn't changed. But rather than nest in this statement, we can just also check if the region equals East to make my other category. So in general, if you can use else if rather than nested statements, it's a good thing to keep in mind. The other piece to note here is to front load the logic, to put the tests first that you think your data is going to hit the most. So in this pretty obvious example, right, if the percentile, if we're in the 75th percentile, then that's the populace. By definition, I know 75% of the time, once the data runs through this, it's going to match that condition, and I don't even have to run the rest of the statement. So if I know that there's a test that is more likely to be hit than others, just put it first, because then you're ensuring that you're running multiple tests less time. So in general, with string calculations, you just want to ask yourself, can I store the data? Does it make sense to do it after the data has been brought in? Or is that something I really should materialize on the back end? And then finally, can I simplify the expression? Can I front load the logic? Or are there two returns and I don't need, I can just do a Boolean return in order to just ensure that if I am using string calculations, I'm doing it in the most efficient way possible. Are there any questions so far on general string calculations? No. OK. All right. So our next larger group we're going to focus on here are table calculations, right? So just a brief example, if we drop on sum of sales, we're looking at this at the monthly level, we could throw on a percent difference. And then this is going to compute to me the percent difference from February compared to January, March compared to February, et cetera. If I changed the view, if I rolled this up to the year itself, I'd get completely different numbers because now I'm looking at the percent difference year over year rather than month over month. So because of this dynamic way of table calculations to compute results just based on what's on the view, right, they're not typically stored on the database because it wouldn't really make sense for me to have to store the percent difference of my years and my months and my days and try to guess all of the questions my business users are going to eventually want to ask. So typically, we're not going to see big performance implications with table calcs. If you keep your view still at an aggregation that's not causing it to compute layout of something that's pretty insane. But where we do run into issues with table calculations is this exact scenario. So when we use them to solve something that they were never designed to solve. So a lot of you that were here before 9.0 can probably relate to this sentiment of using table calculations and other calculations to get past the fact that we couldn't do a level of detail expressions at the time. So there is a lot of workaround ways to get to the right answer, but not using table calculations in the quick, dynamic way that they were always designed to be used. So our next use case here is looking for the most recent day's profit ratio for each of my subcategories. So I have 17 subcategories, and I want to run an easy calculation, right? I just want to run the sum of profit divided by the sum of sales only for the last day of each of my subcategories. So why wouldn't I just be able to look at the max date? Right? Well, we need the last day dependent on each of my subcategories, not my max date overall. And so not every subcategory was necessarily purchased on every day. So in this very simplified table, right, I have art whose last purchase day was November 4th. Furnishings, whose last purchase day was November 9th. Tables, November 6th. If I added in just a max date filter on this, the only thing that would be returned to me would be November 9th furnishings, right? Everything else would drop off. So could anyone think of a table calculation that could look for the last time something was entered rather than the last day? Yeah. Looked at my slides. Okay, so what does last do? So last returns the number of rows between the current row and the last row. So there aren't actually 6 days in between Halloween and November 9th, right? The Tableau is just looking at the points on the view, or the rows on the view, and so it uses that to count down. So I know that my last point on the view is always going to mean last equals 0, and it's not actually looking at the date value. So I can use that as a filter, right? Last equals 0 will only keep the last day of data, and then we will need to use some compute using to do that for each of my subcategory. So I'll want to run that on my subcategories and order dates. And most importantly, I'll want to restart every category. So now this will count down all of my days a particular subcategory was purchased. The last day of purchase, it'll say last equals 0. For my next subcategory, it will restart that entire process. So my last equals 0 filter is going to correctly keep just the last day that a purchase was made for each of my subcategories. So it works correctly for the end user and for that view. However, can anyone tell me the problem with this? Or something to keep in mind? Data needs to be sorted. Yep, I'm just not good at taking screenshots on that one. You would need to make sure you're computing against the right things for the table calculation to work. But actually, we're going to be focusing on when table calculation filters run. So table calculation filters is the last thing in our order of operations to run. And that profit ratio that we're computing on the daily level, that's already run. So a table calculation filter actually just hides what's on the view, but it doesn't change the query that's going back to the database or the extract. So this is actually what we're computing. We're computing a profit ratio for every subcategory on every day that there is a purchase. And the last equals 0 filter hides that from our end users, but it doesn't change that this is still what we're doing. Right, so logically, it would make sense for us to filter on this date first and then run our profit ratios so that we're not running unnecessary calculations that our end users don't care about in the end. Right, so we're going to come back to the solution to this problem. But for table calculations, we'll just want to think about, is the answer dynamic? If it is, likely we'll want to keep it as a table calculation. But also, what is hidden? So are we using heavy table calculation filters? And are those necessary? Or is there a more streamlined way to do that so we're not running a lot of things that our end users don't care about? Are there any table-specific questions? No? OK. All right. So really the meat, if you will, of this session is going to be spent right here. Can I get a quick sense of how many people have used the level of detail expression before? OK, so yeah, I'd say that's like 4/5, 3/4 of the room. And how many of you are comfortable or like understand what a level of detail expression does? OK, a lot less. All right, so we're first going to just go through a more simplified example of what's being run back with the level of detail expression, and then we'll kind of build upon that. So at the lowest level, right, what is the level of detail? The level of detail is defined by any dimension that you bring onto your row or your columns or your marks card. So any dimension that you bring onto the view is what Tableau sees as the level of detail. Now, there's a lot of use cases in which you want to return something, but you don't want that dimension on your view. And that's exactly the example that we'll go over. So I want to know how many of my customers are profitable. This is a very simplified table. I have 5 customers. 4 of them are profitable. Each of them has purchased multiple times. And each order ID corresponds to either a negative or a profitable profit. Negative or positive profit. So I can set up a calculation to easily check if something is profitable or not. Now, this correctly returns a result for every row. But I want to know which individual customers as a whole are profitable, right? And Aaron Bergman returns false, true, true, even though we know if we added up all of his profit amounts, he would be one of our profitable customers. So we're not really looking for a row-level calculation, right? What we're looking for is the sum of Aaron's profits to know if he's a profitable customer. So now we can write a calculation that says the aggregate of our profitable amounts, so the sum of profit is greater than 0. And this works completely fine when we have customer name on the view. At this point, our view is defined by our dimension customer name, which is on our row shelf. So Tableau returns the sum of profit for the level of detail of our view. So I can easily see with the colors that I have 4 profitable customers, 1 unprofitable customer. Now, this works OK with 5 customers, but how about 100 or 10,000, right? I really just want to know a count of how many profitable customers I have and how many are unprofitable. So once I remove customer name from the view, well, now Tableau just sees that the level of detail of the view is just the entire data set, right? There's no other dimension on our view. So it's just showing me my total profit. And if I bring out count distinct of customer name, it's showing me 5 because, well, you're profitable and you have 5 customers. But that's not really considering the test we want to run, right? So if we brought in another table that had our customer name and the profit per customer, then at a row level, I could just evaluate that table. And that's exactly what a level of detail expression does. It fixes it to the detail that we define in order to essentially like force a table that isn't there. So here, if I fix it to the customer name, I'm essentially creating a new table that has 5 rows. And the measure I'm returning is the sum of profit. So for each of my customers, I'm returning 1 profit amount. Now, if I brought out profit per customer in my original table, right, in every row that Aaron's displayed, it would display 129 because now it sees 129 as being Aaron's profitable amount. So now we can evaluate if that is greater than 0. And we can see that it correctly evaluates true, 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 false. So going back to our original question, bringing out our profitable LOD onto the view, and then grabbing a count distinct to customer name, our view is still at the level of detail of our entire data set. But with this additional logic that we built in our calculation, it then runs each of my customer names, see if they fail or pass this test, and returns a count of them. So with level of detail expressions, we can answer questions that ordinarily would have required another table. Now, for those of you that raised your hand for having performed a level of detail expression before, but not understanding it, was that helpful? Or are there any questions on that? Yeah?
So the first part in this LOD is kind of similar to a group by in SQL where it returns a unique list of whatever the metric you put in.
Precisely, yeah. So the question for anyone that didn't hear it was the fix by customer name that we had. It's like a group by in SQL. So really all level of detail expression is a subquery. So yeah, you're exactly right. Yep. So that depends on if you keep a live connection back to your database or extract that. If you extract that, it'll materialize the custom SQL that you run. If you have a live connection, you're running that every time you hit it. So that specific example, I would say with extracts, it would improve performance there slightly. But without, I would recommend using level of detail expressions. All right. So now let's go back to our problem of looking at the profit ratio for all of our subcategories given their last purchase date. So wouldn't it be helpful if I had a table of the last date of each of my subcategories so I could first filter on if the date was equal to this date and then run my profit ratio? Sounds pretty good. So we can use that to create a fixed expression based on that. So we already know our dimension, right? We know we want this at the level of detail of our subcategory. And we know, in this case, it's kind of strange to think of this as a measure, but we know we want to return the last date or max date for each of my subcategories. So with that, we can set up an equation to say fixed subcategory max order date. So for each of my order dates, this is always going to return the date in which there was a last sale. And then check if that equals the order date. So this would be a filter. This will keep potentially 17 days. There could be subcategories that had the same last purchase on the same day. So this will keep the last purchase days for every subcategory. And let's go one more time back to our filter order of operations, right? Fixed is run right after our context filters, but a fixed filter would happen before any of our other calculations. So now that filter would run, and then we would perform the profit ratio. So the result is identical, but we're filtering on those date values first before we run any additional analysis. Does that make sense? Does anyone have any questions there? Yeah?
What exactly is the difference between an extract filter and then a data source filter? Because an extract is based off the data source, right?
Yeah. There isn't if it's an extract. Yeah. It's the same way to apply it. It would just be called different things. But good question. Her question, if anyone didn't hear, sorry about that, the difference between the extract and the data source filter, there isn't. The only time you'd have a data source filter on an extract would be if you extracted the data source and then did a filter. It's just a detail of when the extract is run and if the data source filter applies before or after. All right. So now we're going to go back to the original problem that started this entire session. So just to remind everyone what that problem even was, right? I want to see the last 5 days in which a transaction occurred. In order to do this, we need to check if the database has data, and if it does, look for the next time that happens and do that 5 more times. So not only do we need to find the maximum date, we need to iteratively do this, right? I can't just say, okay, max date and then -5 and keep that, because that's just going to keep to me the calendar dates of the last 5 days without regard to if data was entered on that day. So I'm first going to flash up the finalized equation, and then we're going to take a step back and go through the steps, because if you understand this the way I put it up, you should be up here. So this calculation or these series of calculations would be used to find the last 5 days in which the data is entered. So let's take a step back. Let's pretend I just have a table of 6 order IDs and 6 dates. I'm just highlighting the maximum date in this table so it's easy to see. So let's first start with our equation to find the maximum date. And we're focusing in on this first nested part of that equation, the max date. If you do not fix to any dimension, it's going to return you one number for your data set overall. So fixing this with a colon immediately after is going to give me the last data set overall, so just one number. So that's what fixing to no dimension would do. So first, we're returning the max date. So we can see here the materialization of what that would look like in the table, right? The max date is always going to be November 9th because it sees that there is a date on November 9th, and that's the maximum date. Now, this next step isolates the maximum date. So if the order date equals the maximum date, then the order date. So this goes through and says, well, this doesn't equal the maximum date. This also doesn't equal the maximum date, but this one does, and so it returns the date. In every other scenario, it's going to return null. And finally, this overall expression returns the same date. We actually only need this part of it because we're comparing it to other expressions. That's kind of a further intricacy here. So now we have our last order date. So we have the maximum date in our data set. So now we want to return the second one, right? So this equation has changed. This equation is now the equation that we use to find the second to last order date. So I'm highlighting in blue the date that is actually, no, I'm not. OK, wow, sorry. This one would be the second to last order date. My apologies there. So first, this equation looks at if the order date does not equal the maximum date. How do we know if the order date doesn't equal the maximum date? Well, we have to rerun the first expression, right? In order for us to know that the order date isn't the maximum date, I have to know what the maximum date is. So that goes back to our original equation, checks for the maximum date, says, OK, the order date doesn't equal that, and then we can continue. Then it isolates the second to max order date by taking the max of this expression, which excludes our last order date. So this is going to do the same date or null based on our second to last. And overall, that's just going to return the second to max date, which is the 8th of November for every single row. So in total, this is 47 nested calculations. And that's because in order to know the 5th to the last order date, we have to first know that it isn't equal to the first, which causes us to go back there. It's not equal to the second, which causes us to go here, which causes us to go back there to know what the second is. And we have to continue to do that process for every possible time. Right? You don't need to fully understand this. It should be obvious that this isn't an efficient, good use of resources, right? So instead, what we ended up doing, how we ended up solving this problem for the customer, was to join in a date table with days since last day. So this just requires a bit of SQL in terms of checking if there was an entry and then storing a days descending field, which is just a counter. So again, that doesn't necessarily mean there's 7 days in between the Halloween and November 9th. That just means it's counting the number of days that have happened. So now I can simply join on this new table, matching my order dates together, and then add a filter for if the days descending is in the top 5. So the result is identical, but let's take just a second to look at how this is actually a material difference. So before our query execution, this is just on a 1 million row sample data set, so it's not that large. But running those 47 nested calculations took 0.6 seconds. And doing this with joining our table and then filtering down took 0.05 of a second. So even just against 1 million rows, right, that took 10 times, it was 10 times faster to bring in the table. So with level of detail expressions, oftentimes when you are just using 1 or 2 or even 3, as long as they're not nested, there aren't many performance implications that we've really seen of that. So if it does require another table and you don't have that table materialized or have access to that, using level of detail expressions would be a great way to still get the correct results. Just the driving question there is always going to be how many expressions are being run, right? So how many times do I have to do that? And should I just materialize a table in terms of speeding up that process? All right, well, if there's no more questions, I'll let you guys go 5 minutes early. So thank you for coming.